This video is on the combined gas law. So we've been talking about the ideal gas law, and that's the relationship between pressure, volume, temperature, and the number of moles of gas, or the amount of a gas that we have. This tells you about a gas right now and its conditions that it contains right at this very, very moment. This is the only gas law that has the amount of the gas in it. So if you see a gas law problem that has moles or grams or is asking about the amount of the gas, it's more than likely you're going to have to use the ideal gas law to use it. And that's kind of a thing to remember when you're having to decide which gas law to use. Is that if it mentions the amount of a gas, it's probably the ideal gas law. We're going to talk about another gas law called the combined gas law. This is, like its name implies, a combination of several smaller gas laws, and we kind of talked about the relationship between these different variables the other day. So the relationship between pressure and volume, and pressure and temperature, and volume and temperature. So in the combined gas law, what we're doing is we're comparing the same sample of gas under two different sets of conditions. So the amount of gas remains constant. And these ones and twos refer to two different situations. So this is situation one. So the problem will probably read like, if a gas has this volume at this pressure and temperature, what is its new volume under these new conditions of pressure and temperature? So you're going to have two different sets of conditions, situation one and situation two. You're going to have to read the problem for context clues to figure out and make sure you keep the conditions of each situation separate from one another. Just like with the ideal gas law, temperature must be in Kelvin, and this applies to all gas laws. And again, Kelvin is degrees C plus 273. It's a pretty straightforward gas law. What most students have a problem with is rearranging the equation. So we're going to spend some time talking about that, because if you don't have the equation rearranged correctly, you can't get the problem correct. Okay, so to rearrange this equation and solve for the unknown, what you're going to do is cross multiply. I call it leveling the playing field, so that it's much easier to rearrange if we get rid of all this division. So what we're going to do is cross multiply. So P1 times V1 times T2 is equal to this times this, P2 V2 times T1. This is after we've gotten rid of all the division. Now it's much easier to rearrange. So your first step in using the combined gas law, and you will have the combined gas law on your reference tables. So there it is right there, is to cross multiply and get it into this form right here. Now it's going to be much easier to rearrange and solve for the variable you want to solve for. Like in the example I was just giving, if you want to solve for V2, then you just have to now divide both sides by P2 T1. All right. The other thing is to make sure when you plug in your numbers that you're actually plugging them into the correct spot. The most common mistake is students will put T1 here and T2 here, but that's not the correct reorganization of this gas law. All right, let's see it in action, and we'll work this problem. Now, I will often, when I went through chemistry, we didn't have the nice reference tables that you guys have now, so we had to memorize all our equations. This one was taught to me, and how to memorize it was taught as pole vaulting over trees. So it is PV over T, so pole vaulting over trees. So if I do happen to call this combined gas law equation pole vaulting over trees, it's because it's deeply ingrained in my head. to refer to it that way, but I'll try and refer to it as the combined gas law. And again, pressure, volume, temperature in situation 1 is equal to pressure, volume over temperature in situation 2. All right. So we have this problem right here, and now we're just going to go through and kind of identify our variables. So we have a gas occupying 75 milliliters. That is going to be my first situation, and I'm just going to call that volume 1. And so volume 1 is 75 milliliters. Now, while the ideal gas law had to have volume in liters, the combined gas law, since we have 2 volumes, 2 pressures, 2 temperatures, the units just have to be the same between the variables, and temperature always has to be in Kelvin. Okay, let's see. And then it says at standard conditions. Well, standard conditions for a gas, we know those. That is STP, standard temperature and pressure. If you didn't know them, you could find them here on the front of your reference tables. So we have standard pressure is any of these, and standard temperature is this. We want to pay attention to the Kelvin. All right, so standard pressure is 1 atmosphere, and I'm going to go with 1 atmosphere because I see that my other pressure is also given in atmospheres. If this pressure right here was in millimeters of mercury, at this point I would write 760 millimeters of mercury because that is still standard pressure. All right, and then standard temperature is 273 Kelvin. That is situation 1. All right, now we're going to change the conditions. And you can read it here, is heated to. All right, so we're changing the conditions. So it's heated to 17 degrees C. So my new temperature is 17 degrees C. I need to convert that to Kelvin, and I'm just going to go ahead and do that by adding 273 and end up with 290 Kelvin. While the pressure is reduced, so pressure 2 is 0.97 atm. What is the new volume? So V2 is what I'm looking for. And because this volume is in milliliters, this volume is going to end up being in milliliters as well, but you'll see it as the units work out. All right, so we need to rearrange our equation. So P1 V1 over T1 equals P2 V2 over T2. And the first thing I'm going to do is cross multiply to level this playing field. So P1 times V1 times T2 is equal to this times this. So that's going to be P2 V2 T1. In this problem, I'm going to be solving for V2. So I'm going to circle that, and then I want to move everything away from V2. So I'm going to divide both sides by P2 T1. And they cancel out over here. Now I have my rearranged equation of V2 is equal to P1 V1 T2 over P2 T1. At this point, it is now just plug and chug. Just make sure that you put things where you say they needed to go. All right, so P1 is 1 atmosphere. V1 is 75 milliliters. T2 is 290 Kelvin over P2, 0.97 atm, times T1, which is 273. Again, the most common mistake is students will switch our temperatures and not follow the formula that they just rearranged. Okay, do make sure that you master your calculator, and if you're doing this in one fatal swoop on your calculator, you put everything on the bottom in one set of parentheses. All right, so 75 times 290 divided by 0.97 times 273. And I end up with, and it looks like in the problem, everything had 2 sig figs. So 82 atmospheres cancel, Kelvin cancels. The only thing I have left are milliliters. So 82 milliliters would be my new volume for this particular gas under these new conditions. Okay, so that's how the combined gas law works. It's pretty simple. The hard part is rearranging your equation and plugging everything in correctly. So I have another problem. Take a moment to work this problem out and see what you get, and then and pause this video, and then I will go over the answers. Okay, so with this one, it says what pressure is required to reduce 60 milliliters of a gas at standard conditions to 10 milliliters at a temperature of 25 degrees C. We have to read the context of the problem in order to figure out what situation is what. So if we've got the 60 milliliters, the gas is this volume at standard conditions. So that's going to give us our pressure and temperature. So that's going to be situation 1. Then we're looking for our new pressure under our new conditions. Again, temperature must be in Kelvin. And so here is what I did here. So it's 60 milliliters under standard conditions. And we want to know what the pressure is when the volume is 10 milliliters and the temperature is 25 degrees C. We rearrange our equation, and then we need to solve for P2. So we get P2 is equal to this, and then we're going to plug in our numbers, making sure we put P2 on top and T2 on top and T1 on the bottom as our formula says. Milliliters cancel out, Kelvin cancels out. All I'm left with are atmospheres, and that makes sense for pressure. And I ended up with 6.55 atmospheres since it seemed as though every number that was given in the problem was 3 sig figs. So that's how you work with the combined gas law.